Your Android phone is broadcasting information about you right now, even when you are not connected to any network. It is potentially joining networks automatically that you did not choose and did not authorize. IT is sending your DNS queries, meaning every website you visit, through channels that your internet provider, your employer, or anyone operating a network you connect to can read in plain text. And if you connect to public Wi-Fi anywhere, a coffee shop, an airport, a hotel, there is a realistic chance that your banking credentials or your Google account password have already been exposed without you ever knowing it happened. None of this is your fault. These vulnerabilities exist because your phone shipped with default settings optimized for manufacturer convenience rather than your security. Settings that were configured in an era when the attack tools required to exploit them were expensive and required technical expertise. That era is over. In 2026, the tools needed to execute credential theft attacks, fake network attacks, and device tracking operations cost less than a restaurant meal and required no technical background to operate. The threat environment has changed dramatically. Your default settings have not. In the next 20 minutes, we are going to change that. 6 specific settings, step by step, that move your device from a default open target to something that actually reflects the threat landscape you're operating in. Let's start with the setting that is leaking information about you right now, even with your screen off. Setting 1, MAC address randomization. Every network device has a MAC address. It stands for Media Access Control Address, and it is a unique hardware identifier built into your phone's Wi-Fi chip at the factory. No two devices have the same MAC address. It is, by design, unique to your specific phone. Here's the problem. Your phone broadcasts this identifier constantly as it searches for Wi-Fi networks, even when you're not connected to anything. Every Wi-Fi capable device does this. It is part of how Wi-Fi works, and it is being used to track you. Retail chains, shopping malls, airports, and other high-traffic environments deploy Wi-Fi sensor networks that passively capture the MAC addresses of every device that passes through. They do not need you to connect. They do not need you to accept terms and conditions. Your phone broadcasts its identifier and their sensors record it. Over time, this builds a movement profile. Your phone's unique MAC address appears at this retail location at this time, then at this airport, then at this hotel. The profile can be sold to data brokers, used for targeted advertising, or combined with other data sources to build a remarkably detailed picture of your movements. MAC address randomization is the countermeasure. When enabled, your phone generates a random MAC address for each network it connects to rather than broadcasting your real hardware identifier. The sensors still capture a MAC address, but it is a disposable random value that cannot be linked to your device over time or across locations. On most Android devices, this is already available and may be partially enabled, but the default configuration is often set to use a consistent randomized address per network, meaning you get a different random address for each network, but the same random address every time. You connect to that specific network. This still allows location tracking within a single environment. You want to set this to randomize for each connection or use random MAC, the most aggressive randomization option available. To find this setting, open Settings, tap a Wi-Fi or network and internet, then tap the gear icon or the name of a saved network. Look for privacy or MAC address type, set it to randomized MACs, or use random MAC. Do this for each saved network individually, including your home network. The trade-off is minimal. Some captive portal systems in hotels or airports use your MAC address to remember that you have already accepted their terms. With full randomization, you may need to accept terms again on repeat visits. That is a small inconvenience for a meaningful privacy gain. Setting 2, disable auto-connect on public networks. This setting is responsible for one of the most effective and most underreported attack vectors in the current threat landscape. When your phone saves a public Wi-Fi network, it typically saves it with auto-connect enabled. Every time you're within range of a network with that same name, your phone joins it automatically. This is the convenience feature. You connected to the airport Wi-Fi once, and your phone connects automatically on every subsequent visit without you having to do anything. The attack is called an evil twin or rogue access point. It works like this. An attacker broadcasts a Wi-Fi network using the same name as a trusted network you have previously connected to. Airport free Wi-Fi, Starbucks Wi-Fi, hotel guest network. The name does not have to be unique. It just has to match something in your saved network list. Your phone sees a network matching a saved name and connects automatically. You did not authorize this connection. You did not even know it happened. Your phone is now connected to an attacker-controlled network. From there, the attacker can intercept unencrypted traffic, present fake login pages for banking apps and Google accounts, and inject malicious content into unencrypted web sessions. Modern attack kits that automate this entire process cost very little and require essentially no technical skill to operate. The fix is straightforward. Remove AutoConnect permission from every public network in your saved list. Go to Settings, Wi-Fi or Network and Internet, Saved Networks. You will see a list of every network your phone has ever connected to. Tap each public network, coffee shops, airports, hotels, any network that is not your home or work network, and look for the Auto Connect or Connect Automatically toggle. Turn it off. For your home network, Auto Connect is fine. You control that network. For every public network, Auto Connect is a liability. The 30 seconds it saves you is not worth the attack surface it creates. While you are in your saved networks, also delete any networks you no longer use. Old hotel networks, networks from locations you visited once and will not return to, old apartment building networks. Each saved network is a potential Auto Connect target. The smaller your saved network list, the smaller your attack surface. A captive portal is the login page that appears when you connect to public Wi-Fi. The page that asks you to accept terms, enter an email address, or in some cases enter credentials to access the network. Most people interact with captive portals without thinking about them. They appear, you tap accept or enter the required information, and you move on. Attackers know this. Fake captive portals are one of the simplest and most effective credential theft tools available. An attacker running a rogue access point presents a captive portal page that looks identical to a legitimate login page. It might look like a Google account sign-in. It might look like a banking app login. It might look like the hotel's legitimate portal. You enter your credentials. The attacker captures them. You are redirected to the actual internet and never know anything happened. Protecting against fake captive portals requires a behavioral change more than a settings change. Never enter banking credentials, Google account passwords, or any sensitive credentials through a captive portal. Legitimate public Wi-Fi portals require email addresses, room numbers, or acceptance of terms. They do not require your bank password. If a captive portal asks for credentials that seem disproportionate to the context, you are looking at a fake portal. Disconnect immediately. Additionally, go to Settings, Wi-Fi, and look for a setting called Captive Portal Detection or Network Sign-In Notifications. Keep this enabled. It ensures your phone alerts you when a captive portal is present rather than connecting silently, giving you the opportunity to evaluate the portal before your apps automatically start sending data through the new connection. Setting 4. Verify and enable WPA3 on your home network. Your home network security standard is the lock on your front door. And a significant portion of home networks in 2026 are still running WPA2, a security standard whose password protection can be broken through brute force attacks using tools that run on ordinary consumer hardware. WPA3 is the current generation standard. Its key improvement over WPA2 is a handshake mechanism called simultaneous authentication of equals, which is resistant to the offline dictionary attacks that make WPA2 vulnerable. With WPA2, an attacker can capture your network handshake and then attempt to crack your password offline at their leisure using word lists and processing power. With WPA3, this offline attack approach does not work. Checking your home network standard requires logging into your router's admin interface. The address is typically 192.168.1.1 or 192.168.001 entered into a browser. Your router's documentation or the label on the router itself will show the default admin credentials if you have not changed them. Once logged in, look for wireless security or Wi-Fi security settings. You should see the security mode. If it shows WPA2 only, check whether WPA3 or WPA or WPA3 mixed mode is available as an option. Many routers purchased in the last 4 years support WPA3 but have WPA2 set as the default. Enable WPA3 or WPA2.WPA3 transition mode. Transition mode allows WPA3 capable devices to connect using WPA3, while older devices that only support WPA2 can still connect. This is the most practical option for most households. If your router does not support WPA3, this is worth factoring into your next router purchase decision. The cost difference between WPA2 and WPA3 capable consumer routers is minimal. The security difference is not. Setting 5. Enable private DNS. Every time you visit a website, your phone first sends a DNS query to translate the website name into an IP address. By default, these queries go through your internet provider's DNS servers, and they travel in plain text. Plain text means readable. Your internet provider can see every domain you query. The operator of any network you connect to can see every domain you query. This is not a theoretical concern. ISPs have documented histories of selling DNS query data. Public network operators have no obligation to protect the data flowing through their infrastructure. Private DNS routes your DNS queries through an encrypted channel to a DNS resolver of your choosing. The network operator sees encrypted traffic going to a DNS service. They cannot read the individual queries within it. On Android, private DNS is built into the operating system and takes about 30 seconds to configure. Go to Settings, Network and Internet or Connections, and look for Private DNS. Tap it. You will see 3 options: Off, Automatic, and Private DNS Provider, Host Name. Select Private DNS Provider Host Name. In the field that appears, enter one of the following: DNS Google for Google's encrypted DNS service, or 1111 for Cloudflare's DNS service, which has a strong privacy policy and does not sell query data. Tap Save. Your DNS queries are now encrypted. Your internet provider, your network operator, and anyone monitoring your connection can no longer read the list of websites you visit from your DNS traffic. The final setting is one most people have never opened. Wi-Fi Direct allows devices to connect to each other without a router, using a peer-to-peer Wi-Fi connection. It is used by features like file sharing, wireless printing, and certain casting functions. When Wi-Fi Direct is active and discoverable, your device is visible to other Wi-Fi Direct capable devices in range. In a dense public environment, this means your device is visible to every other device nearby that is scanning for Wi-Fi Direct peers. Go to Settings, Wi-Fi, and look for Wi-Fi Direct. If you're not actively using a feature that requires it, ensure your device is not set to be persistently discoverable. On most Android devices, Wi-Fi Direct visibility is only active when you're in the Wi-Fi Direct menu, but it is worth confirming your device is not in a persistent discovery mode. Similarly, review your hotspot settings. If your phone's hotspot has a weak password or is set to open, any device in range can connect to it and route traffic through your mobile data connection. Go to Settings, Hotspot and Tethering, and verify your hotspot uses WPA3 or at minimum WPA2 and has a strong, unique password. 20 minutes, 6 settings. The difference between a phone that was configured for 2019 convenience and a phone that reflects what the 2026 threat landscape actually looks like. MAC address randomization stops passive location tracking. Disabled autoconnect on public networks blocks evil twin attacks. Captive portal awareness prevents credential theft. WPA3 on your home network closes brute force password vulnerabilities. Private DNS encrypts your browsing activity from network observers. Wi-Fi Direct and hotspot auditing removes unnecessary exposure points. None of these changes cost anything. None of them require technical expertise. All of them take effect immediately. Your phone's default settings were chosen to make setup easy and features convenient. They were not chosen to protect you from the tools that anyone can buy and deploy today for almost nothing. You just changed that.